Hi, my name is Ken Trimber and welcome to the KTA University podcast. Our topic for this podcast is measuring ambient conditions, the different methods that are used, instruments, for determining dew point, relative humidity, surface temperature, air temperature. And my guest today is Bill Corbett. Bill's going to answer the questions for us.
Okay.
Bill, could you start off by telling us the two different types of methods that are used for determining the ambient conditions?
Yeah, ambient conditions can be measured using what we call whirling or sling psychrometers, which is kind of old school, but it's kind of tried and true. And we also have digital psychrometers that can be used to measure the same conditions.
So how is the whirling psychrometer used?
Basically, it consists of two thermometers. One's called a dry bulb, one's called a wet bulb. The dry bulb is measuring the air temperature, and the wet bulb is used to determine the latent heat loss by whirling the instrument through the air until the dry bulb and wet bulb stabilize. And then the relative humidity and dew point are determined using basically psychrometric charts or lookup tables based on the air temperature and actually the delta or the difference between the stable dry bulb and the stable wet bulb measurement.
Okay, so you take readings of the thermometers and then you do some other calculations.
Yes.
All right, how does that compare with the digital equipment?
Well, the digital psychrometers are actually a little more simplistic because they don't work on dry bulb, wet bulb type information. They actually display the air temperature, the relative humidity, the temperature of the dew point, and the surface temperature on a display. The instrument uses a relative humidity sensor, and the dew point is calculated from the relative humidity measurement as well as the air temperature.
So then I just push a couple buttons in this case and get some numbers.
Exactly, yes.
All right, so if I'm in this room and let's say I had the one instrument and you had the other, would the results be the same?
It wouldn't surprise me that they would be different. Even within a rather controlled climate like we have here, the readings could be quite different because they're measuring the conditions slightly differently.
Why would they be? That makes you a little nervous. Why would they be different?
Well, one of the things that we've determined over time is that the digital psychrometers, as I mentioned earlier, they use a relative humidity sensor. And if you store the gauge in an air-conditioned environment or an arid environment, that relative humidity sensor over time will dry out. So you get a false low humidity compared to the whirling psychrometer, which again doesn't use a relative humidity sensor. And what it's doing is it's measuring the latent heat loss from the wet bulb thermometer, and the rate of evaporation into the air determines what the relative humidity is. So there's very little to go wrong with the whirling psychrometer. With the digital psychrometer, the relative humidity sensor could dry out.
So if it dries out, do you replace it? What do you do?
In that case, what the manufacturer recommends is powering the gauge down and wrapping a damp cloth right around the probe overnight. And what that'll do is that'll resaturate the relative humidity sensor. But then when you power up the gauge the next day, you need to let it equilibrate for about 20 to 30 minutes before you take measurements with it, because it's going to have to come down maybe from 95 to 98% relative humidity, since it was saturated, down to the actual relative humidity in the air.
Well, that's interesting. So let me ask you a different question. Let's say that I have my equipment stored in my car and I come out at noon to take readings. The psychrometer, I can sling it and get a reading. Taking the digital out of my car and taking it to the job site, do I have to let it stabilize even then?
Yes. Yeah, the manufacturer of those instruments recommends that if you're taking it from one environment to the other, and if there is enough of a relative humidity difference between the storage environment and the environment you want to use it in, you should let it equilibrate for several minutes. So ironically, a lot of people think that the digital psychrometers are a lot faster than using the whirling psychrometers, but if you have to let it equilibrate for several minutes, you could probably already have your conditions with the whirling psychrometer.
Interesting. So if I do have some differences, would they be a lot or close enough that it shouldn't create a problem in the job?
It depends. For example, if the specification invoked a maximum of 85% humidity, and as long as you don't exceed that amount, whether the humidity is 60% or 50% may not matter a whole lot because you're still below the threshold. But when you get up close to the threshold, it could make or break. But it is a good idea to have an accurate indication of what the humidity really is, because that's what you want to document.
And what about dew point? Are they closer on dew point?
They are a little bit closer, but what you'll find is that the dew point is typically derived from the relative humidity reading. So if the relative humidity reading is off, the dew point temperature may be off as well. And that could be even more critical because we're comparing the dew point temperature to the surface temperature. And typically the tolerances are a lot less for those.
So it almost sounds like, although the digital might be more efficient in some ways, the old sling psychrometer may be I don't want to say the better of the two, but possibly the more accurate of the two, because it isn't prone to these types of errors.
Yeah, the way that the whirling psychrometer works is very basic. Again, it's tried and true. The way the digital psychrometers work, there is potential for error depending on what environment you're taking it out of and what environment you're using it in.
Interesting. All right, what about if I'm, some coatings, moisture cure, I could apply it under 20 degrees. You're saying water is involved, so it's going to freeze.
Yes.
How do I take readings then?
Yeah, so in this case, if you tried to put water onto the wick on the end of the wet bulb, it would freeze. So it would not work. Fortunately, most of the digital psychrometers can read down to minus 40 degrees. So they can be used well below freezing and still give you accurate measurements.
Okay, interesting. So there's a plus for the digital.
Yes.
Interesting. What about calibration or verification of accuracy, things like that?
Yeah, both instruments should be calibrated or at least verified for their accuracy. Now, the whirling psychrometers, of course, there's no way to truly adjust thermometers. So all that the service center or manufacturer of the gauge can do is simply compare the thermometers to a referee thermometer or a traceable thermometer to make sure it's within tolerance. The digital psychrometers, those can be adjusted by the manufacturer or their authorized service center.
Okay.
And typically that's done on an annual basis. There is no way to verify the accuracy of those instruments actually in the field.
Okay. Another question, we compare surface temperature with dew point. With the sling psychrometer, there's no surface temperature integral to it.
Correct.
So you get a separate gauge. What about for the digital equipment?
So with the whirling psychrometer, you have to have a separate instrument, either a thermocouple type or a dial type thermometer to measure surface temperature. And some people even use some non-contact infrared pyrometers for that. With the digital psychrometers, most of them come with a built-in surface temperature probe. That can also be non-contact infrared. And some of the digital psychrometers also come with a hot wire so you can measure wind speed as well.
That's excellent. Well, I think that covers it, unless you have any last comments.
No, I mean, I think what you'll run across in the field is, if maybe a quality control inspector is using one instrument and the quality assurance inspector is using either a digital psychrometer or a whirling psychrometer, the opposite, there could be differences. So what I'd recommend is maybe at the pre-job conference, decide on what technology is going to be used on the job so that we're both using the same types of instruments.
Good advice. Excellent. Well, that's the end of this podcast. Please log on to KTAUniversity.com for other podcasts.